So this is going to be a little different than some of the other talks, at least the ones I attended yesterday, were very much deep dives. And what I want to do instead is talk about, first, architecture for AI and GenAI systems and the implications of GenAI, both on architecture as well as architects, because our jobs are different when we're dealing with systems like AI. And of course, given the pace of change, this will all be out of date on Monday. So don't worry. So I want to start with talking about the models, because there's actually two aspects to the models. The first is what model you're going to use and how you're going to serve it and how your application is going to serve results as the basis of this model. And then there's the question of training. And I'm going to start with training. I heard an interesting statistic. I was wondering about this, but had never researched it. But in Lars's talk yesterday, he mentioned the fact that it costs $65 million approximately, this is an estimate, for one training run on one of these foundational large language models. So you probably don't want to do it. In the early days of GenAI, we actually had clients who were asking us, can you train an LLM for me? And it's like, no, you don't want to do that. The energy requirements, the cost, the data requirements. So let somebody else worry about that. Now, the standard response to that is but. I have all of my proprietary knowledge that isn't in there. Or I want to specialize it to my context, or I want it to, when it creates text, I want it to create it in a particular voice. I have a colleague or a friend who's a CTO, and he actually trained up one of these open source models with all of the things he had ever written. And he came up with an app that was roughly Ask Mike. And it answered in his voice. But he didn't train the whole model. He just said, oh, by the way, here's some other stuff. And one of the things, by the way, that we put on the radar a couple of editions ago was to put premature fine-tuning on hold. Because when you think about what fine-tuning is, you're fiddling with the parameters that all of that training, all of those $65 million iterations came up with. And so you want to be cautious. RAG is proving to be quite a useful architecture, retrieval augmented generation, where you're effectively saying, hey, give this stuff priority with what you're looking at. But the point is, for large language models, don't train them yourself. Now, this is different than plain old AI. If you're doing pattern recognition or clustering on your data, it's perfectly sensible for you to do all that training yourself because you don't need to rely on that. Those foundational models serve a very different purpose. With these foundational models, you have the ability for your users to interact in natural language. So they're giving you a completely different entry vector. What you do with that entry vector, how you use that, is the big question that you have. And I'll talk a little bit more about some applications later. However, there are also using the same kind of model creation techniques, just with different data sets. We're seeing some really exciting progress in things like the modeling of the three-dimensional structure of a protein, which allows you to do a much better job of finding potential drugs to solve diseases. Now, I worked in this particular field 20 years ago, roughly, and the state of the art then was you send a team into the Amazon and they collect all kinds of specimens and you bring them back and you put them on a sheet. And then you smear the sheet with the disease, your target, if you will, and then metaphorically you shake it. And if the stuff doesn't fall off, it's a good candidate to be a drug. Doesn't that sound like a scientific, rigorous process that's underlying this? But what we're finding is you can use that same algorithm to train a model to predict relatively close what the likely structure of that will be. And so now we can look at designing drugs in a very different way. Now, what about serving up models to be used? Most of the entities that we worry about are still here. There are some interesting takes on them. What about security? We do all this work to try to make sure that the LLM doesn't say anything bad, and then people figure out how to get around it. And unfortunately, although a bigger context window makes it easier for us to get the kind of answers we want, what they're finding is it's also easier in a larger context window to be able to jailbreak across those protections. There are lots of guardrails that are out there to allow us to control how these things actually operate. Latency is a big deal, particularly with how complex these models are. And as observability, we have to think about observability in a different way. Because when we build transactional systems, we're reasonably confident what the output is going to be. And it's more, is it responding? Has it crashed? Has the network crashed? All of those kinds of things. Observability in this context is also, is this thing making sense? And it isn't always making sense. And so we are probably going to be seeing the construction of lots of things which, in an evolutionary architecture context, we call fitness functions. You might just call them tests. They're nothing special, but it's an objective, specific identification of this is what I expect from my system. And we need to be able to keep track of how these systems are performing, particularly if you're in a situation where reinforcement learning is going on and the model actually has a chance to change itself. But let's not forget the biggies. Hallucinations. I've seen all kinds of debates on whether or not this is the right word or not. But unfortunately, I'm here to tell you that this is a feature, not a bug. How in the world is one of these models supposed to create a story in the style of William Faulkner about a particular event in the American South if it can't make anything up? It's got to be a new story. It just has to sound like him. The whole point of these things is to generate new stuff. So to expect that it's never going to make anything up just doesn't make sense. And remember, these models are trained to be helpful and agreeable, but they will just output whatever they come across in their search of the model space. One of my favorite hallucinations, I have a colleague who put together a spreadsheet of the technologies that were used in various years on our different projects. And he loaded that into one of the LLMs and asked what the most popular technology in the year 2022 was. And he got a short story back. And the final paragraph of the short story was roughly, I am not a farmer sowing seeds in a field. I am an arborist planting and nurturing a tree that in 100 years will contain a village. Never heard of that technology. It's creative, though. Non-determinism. One of the interesting things about dealing with people who do not understand the technology landscape is they have their mental model of how technology works. And computers, if you ask it the same question twice, in the same context, are supposed to give you the same answer. Nope. Again, it's not a bug, it's a feature. And of course, the inappropriate responses. These, in some ways, are the easiest to control because you can do various kinds of sentiment analysis, et cetera. And you've got this LLM that understands language, so this is probably the easiest to get around. Okay, so let's talk about architecture. This is the conceptual stack that I want to discuss. There are implications for hardware, for infrastructure more broadly, models, tools, and applications. It's not just the GPU anymore. There's a lot of interesting work going on in hardware for those of you who are interested in chip design on even more specialized chips to handle various aspects of this whole LLM process. There's work going on to design caches in such a way that you can get better response time, lower latency, even given the massive memory requirements of these models. But again, unless you work for NVIDIA, let somebody else worry about it. Now, where to run? Publicly hosted. Should you do it on-prem? Do you want to build this to be agnostic of your hosting provider, or do you want to take advantage of those specialized? The answer might even be different for different applications within the same organization. But these are the kinds of questions you have to ask. And then which model? How do you evaluate? You've got all of these benchmarks and all of these leaderboards, but the benchmarks all measure different kinds of things. So you need to think about what it is that you're trying to achieve and do some initial experimentation on which of these models is actually going to give you the best performance. Do you want it to be open sourced? Or do you want it to be closed sourced? Do you want your data to be used to tune the model, or do you want to keep your data to yourself? Are you just looking for standard language processing, or do you need one of these more specialized models? Are you going to fine-tune? You have this entire list of questions which is just about picking the model. And now let's talk about the problem. They're running out of data. Now, when you think about how much data that gets produced every day, the fact that they might be running out of data is a scary thought anyway. But if you also think about how these models learn, if they start being trained on their own output, all of the biases that already exist in there are going to be amplified. All of the responses are going to be homogenized. And so, in one sense, the models are as bad as they're ever going to be because they're going to continue to get better. But in another sense, depending on how this synthetic data is used to train models, the models might actually get worse. Tools. The big one, of course, that everybody talks about is Copilot. More broadly, the coding assistants. I've heard people say that junior developers will no longer exist. I would pose the question, where do people like you sitting in this room, but 20 years from now, where do you come from if there are no more junior developers? We got to think about that problem. Question answers, of course, like ChatGPT. There are lots of tools out there to build different kinds of guardrails for you so that you can protect data going in and out, things around PII, bias, relevancy. And there are also lots of tools that are being developed for the space of LLM ops. I mean, first you had DevOps, and now you've got DevSecOps, and you've got all of these other ops, and of course we have to have LLM ops. Applications. One of the things that I find very interesting about GenAI is, in the past, the people who interacted with AI were computer scientists and AI researchers. Now you have plumbers and marketing people and accountants and finance people and ... interacting directly with an artificial intelligence system. This both really excites me and really scares me. It scares me because they don't necessarily understand how this works, and that's how you get things like the list that was generated of professors that were known to be sexual harassers, which was completely made up. So there were people on that list whose reputations were damaged because somebody decided to put together this list. The good news is the people who are going to be thinking about how to make AI work in this context, the pool is so much broader than it was before. Somebody in marketing is going to sit there and think, how can I use AI to create this campaign? Someone in a law office, hopefully they'll check their work. There are the lawyers in the US, for example, who have been cited for contempt of court because they presented a completely made-up case in a brief. But there's a lot of work that legal assistants do that couldn't be done with an AI system. And you've got people who are doing those jobs who can now say, how can I do my job better using AI? I don't remember which talk it was yesterday, but somebody put up the quote that effectively says, I don't want the AI to do blah, 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 so that I have more time to do the laundry. I want the AI to do the laundry. What are the things that the AI can do that will free up the time of the human to do the things that a human can do much better? One of the very interesting applications, I think, is this document answering, where you specialize an LLM for a particular document. And rather than having to do text search and figure out, okay, where is it going to explain the travel policy to me, you ask it, what is the travel policy under this condition? And it gives you an answer. The potential in knowledge management for something like a system that answers questions on the basis of internal documents is enormous. The number of times people have said to me, if only we had a better knowledge management system. It was before fire was invented, I think, the first time. I want to tell you about this last application, though, called Jugalbandi. And this is something that ThoughtWorks built in conjunction with an NGO in India. And it married a RAG architecture with an input mechanism that did Indic speech to English and back translation, also going to text. And what this system was designed to do initially is take the welfare schemes that the Indian government made available and allow someone with just a cell phone, just a voice interface like WhatsApp, to ask, what housing support schemes am I eligible for? And it will ask questions about the particular person's situation, where they live, what their demographics are, And then it will come back after having scraped and gone through this kind of document answering process with the portion of the Indian government website that discusses the scheme and talks the person through what they have to do to apply for benefits. Now, rural India still has a significant population of people who are illiterate, so having it be speech to text is incredibly important. Obviously, this was a situation where hallucinations had to be very tightly controlled. That's where the RAG architecture came in, as well as many other guardrails. But this is something that would not have been possible without this technology. Now I want to talk about a few patterns. There's still a lot that's emerging. There's lots of experimentation going on right now, but these are some. Serverless is playing actually quite an interesting role as are microservices. When we start talking about bringing a mobile phone into the mix, or we talk about potentially inputs coming from edge devices, I think we're going to see even more heterogeneity in the way these systems operate. Of course, RAG has made a real difference in terms of being able to take advantage of the foundational capabilities of the large language models, as well as being able to contextualize it in such a way. Because yes, you have a temperature parameter to control hallucinations, but that's a pretty blunt instrument. And so being able to provide that additional context through the RAG architecture has been valuable. And more, we have integration with other resources where the large language models can go out and ask a question of the internet. The recent release of Claude can actually use a computer. Now that kind of frightens me a little bit. It's one thing for it to tell a person, type this into the computer. It's another thing to think that it could wipe out your entire directory if it decided to, because it thought that was a really good idea because you were running out of disk space. So some things should perhaps be used with a bit more caution. Multi-agent systems. That's one of the things actually I expected to see more of here, but you can only be in one place at a time. But lots of people are talking about the power of multi-agent systems. But we're still trying to figure out exactly how to make these systems work. An important part of an agent is its autonomy. It can't be something human in the loop and be an agent based on the established definition of an agent. Some people will say it can't really be an agent unless it can somehow interact outside of its own space. That's a little more contentious. But over there on the right, there are a lot of issues you have to think about if you want to build a multi-agent system. What's the topography going to be? Is it going to be like an old-fashioned blackboard architecture where you've got different agents looking at a problem from their particular perspective and proposing answers? Is it going to be like the architecture used to create the system that defeated the Go champion, which was actually a very simple model of put two of them playing against each other completely autonomously and let them develop strategies to see how they do? A more competing or competitive model? Or should they be more collaborative? Should you maybe have one LLM that is checking the answers in some way for another LLM? What is the granularity of your agents? Should you think of this, again, like the Blackboard architecture, as a mixture of experts? We've got different ways we're going to try to solve this problem. This should not be the first tool you reach for in trying to solve a problem. Eventually, I think we're going to see a lot more multi-agent systems, but we're still really trying to figure out how to make this work. That's really the same prominent list of abilities. I do want to emphasize again the importance of observability. We need to know what these systems are doing. And this is not the same kind of just operations observability we've had in the past. And then privacy is another big concern. And it's not just privacy from the context of PII, this list of harassers, university professor harassers. That was a privacy violation. It only had the person's name. That person was in the public because of publications, et cetera. But that was a privacy violation. I mentioned experimentation earlier. I haven't heard an updated figure. I hope it's better. But as of the middle of this year, of all of the proofs of concepts that were begun in 2023, a single-digit percentage of them were actually in production. And when you think about that, that's not that surprising. These systems rely on clean data. It's one thing to scrub data for a pilot group, for 10 people or 100 people. It's another thing to figure out how to scrub that same data for 100,000 people or across the broad range of the demographics. And that's just one problem. With that smaller pilot group, you can keep control over the consequences of things that go wrong. Some people who put things into production regretted it. My personal favorite, Air Canada. They deployed a customer service chatbot. And somebody interacted with the chatbot and said that they had a death in the family and they wanted to take advantage of the bereavement refund policy. And the chatbot, being agreeable, cheerfully laid out the terms of this policy that does not exist. And a judge held that Air Canada had to honor it because this person operated in good faith and their representative, the chatbot, told them they could get a refund. So clearly, there's still some work we need to do about understanding the risks. But this is a real problem. This whole, how do we get these things into production at the scale we want? How do we understand the risk and explain to our chief risk officer and our CEO the risks that they're running when they deploy these systems? It's much easier to talk about the benefits. Oh, we can do all of this stuff. And it's like, yeah, but at what cost and with what risk? Now, what about architects? What about the people like you? Well, it was bad enough before. I don't know how many of you had the joy of trying to describe to a CFO that eventual consistency was really okay. Like I said about determinism, people who don't understand technology have a very simple view of how databases work. You put something in, and it's in. And if you go look again, it's in. And eventual consistency, well, you'll get there eventually. But I got to have those conversations. And getting people to wrap their head around, no, it's not guaranteed instantaneously to be there, but don't worry, it will be. And, oh, don't worry, we won't use that on people's checking account balances because that would be very bad. Now we have to do it with things like hallucinations and non-determinism. But we have other issues too, some of which flow from the speed at which, for example, these coding assistants can generate code. Some of the analysis that has been done has shown that the average commit size is going up. And the hypothesis is that these code generators are much better at creating new code than they are at refactoring. CodeScene did an analysis of refactorings, and they tested it across multiple coding models. And the best any of the models did in terms of being able to correctly refactor a piece of code was 33%. Now, how many of you think that you would keep your job if you got it wrong 2/3 of the time? So we know we're getting lots of code, and what do we know about the increase in code size? If you have more code, you have more bugs. If you have more code, it's harder to understand the code that you have because there's more of it to understand. And so we are creating a mountain of code that may not be very good. So how, as an enterprise architect, do you start thinking about corporate coding standards? We haven't really figured out yet how to tell systems like Copilot, and oh, by the way, these are our enterprise patterns that we like and all of that. So how is an architect supposed to keep control of this sprawling estate of code when a lot of it's being generated? I still can't decide whether I think it's a good thing or a bad thing, but Google very recently proudly announced that 25% of their code was now being generated by code generators. Like I say, I can't decide whether that's a good thing or a bad thing. And what is one of the fundamental roles of an enterprise architect? It's to maintain the overall asset value of the IT estate and keep some kind of unifying vision of how things get done. How do you do that if 25% of your code is being generated by a coding assistant? Testing is a fascinating area. This is true even for good old-fashioned AI. If you run a pattern recognition algorithm across a data set and it doesn't come back with the kind of pattern you were expecting, there are two possible answers. One is your code's wrong. But the second is that there isn't actually a pattern in there that is of the level of utility that you're asking for. Just because you have a lot of data doesn't mean it's going to give you a useful pattern. Maybe the pattern is not obvious. Maybe the pattern isn't strong enough yet to be visible. Maybe there isn't actually an underlying system to the generation of this data. So do you have a bug? Or do you just need to look elsewhere for something to solve your problem? As I said earlier, benchmarks are useful, but you also want to use evals to understand the behavior of your model or your application in various contexts. And then you probably want to have some tests that you put in your CI pipeline, your build pipeline, that ensures that the behavior is staying within what you have deemed to be acceptable grounds. There's still a lot of research going on, though, in how do we test applications using these models? How do we evaluate the effectiveness of these different models? And then finally, ML ops, LLM ops. We really have to think about what are our artifacts when you have an application that is being generated because it's been trained on a particular data set and came to a particular result. And these trainings are not necessarily deterministic either. And so how do you have that degree of reproducibility and traceability and potentially auditability? We need to have a continuous delivery process that understands it's no longer just the code artifact, but it's also the model and the data that generated the model. And so if you want to recreate your system, you need to make sure that you have the data that was used to train the model that was used to create the system, or you don't have that level of recoverability. I already talked a little bit about this, but there are some interesting approaches. For example, having one LLM check the result of another LLM and using that as part of your testing strategy. Red teaming is being used quite effectively here, as well as deliberate attempts at jailbreaking and then understanding, okay, what do we need to do to close off that particular vector? And I do think we're going to have to think about new ways of communicating and encoding the standards that we have. Some of that is going to be dynamic fitness functions used for monitoring and observability. I do think it's an interesting question. Are there ways that we can use algorithms that we can use similar to what we do with documents to embed particular standards in a coding assistant? I think it's pretty clear, though, that like all business processes, AI and GenAI is going to reshape how we do it. Different individuals are going to sit and say, how can I better achieve my task? Whether this is somebody who is collecting requirements. These systems, these LLMs, are actually very, very good for brainstorming. They make a really nice brainstorming partner because they like to think outside the box. They want to come up with something different. They want to be helpful. They want you to see new ideas. And so this isn't just about coding. It's about the entire software delivery lifecycle. And as a reminder, given the pace of change, this will all be out of date by Monday. Now, I want to caveat this time, because there is a lot of evolution going on. There is something of an arms race going on between the models. Although they're trained on fundamentally the same data, they kind of do things a little bit differently. But we see breakthroughs. And then we see a period of, okay, everybody's rushing to get to the same breakthrough. And then nothing seems to happen for a while. And then we see another breakthrough. And I think that's what we're going to continue to see in the evolution of these tools, is it is not going to be a straight line. Thank you very much.